Good morning or afternoon, I guess, whenever you're watching this. This is going to be the lecture for Chapter 1, Section 1, which is over graphs and graphing utilities. And so the first thing that we are going to talk about today is the Cartesian coordinate system. And this system was designed by a French mathematician named René Descartes. And this system looks like this. This is a Cartesian coordinate system. It is made up of an x-axis, which is your horizontal, and a y-axis, which is your vertical. So I'm going to write x-axis is horizontal, y-axis is your vertical. And what you notice is whenever you have your x and your y-axis, they're going to intersect, and where they intersect is the point called the origin. And then it also cuts your Cartesian, the plane, into 4 sections. And what we do is we call this one quadrant 1, the upper right-hand corner, and we label it with a Roman numeral 1. Then we go counterclockwise in order to number the rest of our quadrants. So we go to the left, and the upper left one is quadrant 2. Lower left is quadrant 3, and lower right is quadrant 4. Those are the 4 various quadrants. Now, when we want to talk about a point, like the origin, or a point within any of our quadrants, we call those ordered pairs. And an ordered pair is going to be of the form x, y. You're going to have an x point and a y point, and that's going to tell you where on our Cartesian coordinate system we are going to find that actual point. One thing to note about the Cartesian coordinate system is as you move right, you are moving towards the positive side, and as you move up, you are moving towards the positive side. So the points that are in quadrant 1 are both going to be positive. Your x's are positive and your y's are positive. Over in quadrant 2, your x's are negative because you're to the left of the origin, but your y values are still positive because you are up from the origin. In quadrant 3, you will have negative, negative, because you're negative on your x's and you're negative on your y's. In quadrant 4, you will have positive on your x's and negative on your y's. Okay? So let's move down and we will plot some points on our Cartesian system. Okay, I know that's a little angled and I'm sorry about that. There's not a good table set far enough away. So for this example, we have our Cartesian coordinate system, our plane, and we are going to plot the points that they gave us. So the first point that they gave us is point A. And point A is at -3, +5. The first number is always your x value. So that tells you how far left or right you're going to go along your x-axis. And it's at a -3. So we start at our origin and we go 1, 2, 3. Then it's at a +5. So we go up 5. 1, 2, 3, 4, 5. So right there is point A. B is a +2 and a -4. So we go to the right 2 and then down 1, 2, 3, 4. There's point B. C, we have 5, 0. So we're going to go 1, 2, 3, 4, 5, and then our y value was 0. So we don't have to go up or down. We're just going to stay right there on the x-axis for our point C. D was -5, -3. So we go left, -5, 1, 2, 3, 4, 5, and down 3, 1, 2, 3. For point D. E was at 0, 4. So remember, x is our first value, so that means we don't go left or right at all. We're just going to go up 4. 1, 2, 3, 4. And that leaves us on the y-axis for point E. So just like on C, we don't necessarily have to be off our axis in order to plot our point. So our last point is point F, which is 0, 0. So we're not going to move left or right. We're not going to move up or down. The point 0, 0 is also known as the origin. So F is the point of origin. Okay. So I want to make a note over here because we're going to start talking about equations. Simply, an equation in two variables, so in an x and a y, is going to show a relationship between two different quantities. So we're going to go to the back of the room now, and we are going to learn how to graph an equation using the point plotting method. Use the point plotting method to graph the equation y equals 4 minus x squared. So what is the point plotting method? Well, what that means is we plug in values for our x, figure out what our y value is, and then plot the point. So the easiest way to do these is to make yourself a table. We have an x, and we have y equals 4 minus x squared. And then we would have our y column, or I usually put it as an xy column. So I just get a nice point column over here, and then this is the only column I need to actually do my graphing, and it makes it a lot nicer. And so they always recommend that you do about 5 points. So I usually do 2 negative points, I do 0, and then I do 2 positive points. That way I know what's going on in my graph. I did just pick these points arbitrarily. You could pick any point you wanted. However, if you go a little bit in the negative and a little bit in the positive and you do the point 0, that's going to give you a pretty good representation of what your graph is doing. So at x equals -2, what we do for that is we plug it into our equation anywhere that there's an x in order to figure out what our new y is. So we have 4 minus, and then we have -2 squared. You do have to be careful that you put that negative inside the parentheses because that squaring happens to both the 2 and the negative. So that's 4 minus 4, which equals 0. That means my point at -2, I have a value for my y at 0. 4 minus a -1 squared, 4, and then that's going to be a positive 1, but I still have that minus out front. -1 equals 3. So when x is -1, my y is 3. 4 minus 0 squared equals 4. So when x is 0, y is 4. 4 minus 1 squared equals 4 minus 1, which equals 3. So at 1 we have 3. 4 minus 2 squared equals 4 minus 4, which equals 0. So this one has a little bit of symmetry in it. 2, 0. So now I come over to my graph and I start plotting those points. So I had -2, 0. So -2, 0. -1 up to 3. At 0, I was at 4. At 1, I was at 3. And then at 2, I was back down at 0 again. I just plotted the points we found, and then I'm going to connect them. And we get an upside down parabola or quadratic. You don't necessarily have to know that right off the bat. We'll have a whole chapter on quadratics later on in the semester. But this is how it looks. We're going to do another one. Put on down the board. Remember, at any point, you can obviously just pause the video if you need more time to write something or take notes or work out the problem yourself. So in this case, we have y equals the absolute value of x. Maybe you don't remember what the absolute value of x means. The absolute value simply means the distance away from 0. So on your number line, we have 0, 1, 2, -1, -2. So the absolute value of 2 is simply 2 because the number 2 is 2 units away from 0. The absolute value of -2 is also 2 because -2 is also 2 units away from 0. So that's what an absolute value means. So again, I'm going to use the point plotting method. So I have y equals absolute value of x, and then I have my x, y. Again, I'm going to use the exact same numbers for my x values that I chose for the last problem. I'm going to have -2, -1, 0, 1, and 2. So at -2, I have absolute value of -2, which is 2. So when x is -2, y is 2. Absolute value of -1 is 1, -1, 1. Absolute value of 0, well, how far away is 0 from itself? 0 units. So 0, 0. Absolute value of 1 is 1. So 1, 1. Absolute value of 2 is 2, 2, 2. So I had -2, +2. -1, +1, 0, 0, 1, 1, and 2, 2. So the graph of an absolute value function is going to look like a V. And notice it's not negative because you can't have a negative absolute value. Everything gives you a positive answer. Next, we are going to talk about intercepts. Intercepts are just basically where our graph crosses the x and y axis. So our x-intercept is where a graph intersects the x-axis, where a y-intercept is where a graph intersects the y-axis. So we're going to look at some graphs and we're going to figure out our x and our y axis based on the graph. So for this first graph, we have a straight line and we need to figure out our x and our y intercepts. So our x-intercept is where it crosses the x-axis. Well, if we look at this graph, it crosses the x-axis at -1. That means I don't know why I did that. -1, 0. An x-axis will always have a 0 at our y because that's when it's, or our x-intercept will always have a 0 at the y value because it's at the x-axis. So similarly, our y will always have a 0 in the x place because that's the value of x at the y-axis. So our y-intercept for this line is up 1 unit. So that's at the point 0, 1. Okay, let's look at the second graph. We have a vertical line at x equals 3. So what is our x-intercept? Well, it intersects the x-axis at 3. So that is 3, 0. Now what is our y-intercept? Where does it cross the y-axis? Well, it doesn't, and it never will because it is a horizontal line. So that means we have no or none y-intercepts. It will never cross. Okay. So what about this line? Where does it cross the x-axis? Well, it crosses at the origin, which is the point 0, 0. Well, if it crosses at the origin for the x-axis, or the x-intercept, then what do you think the y-intercept is? Also 0, 0. Notice it doesn't cross the y-axis anywhere else. So the origin can be the answer for both, and that's okay. Now, let's look at this crazy last one. That is a absolute value equation. We know that because it looks like a B. And for this one, I'm going to start with my y-intercept. Where is my y-intercept? Well, where does it cross the y-axis? It crosses it at the point -3. So that's at 0, -3. Now, where is my x-axis, or my x-intercepts? Well, my x-intercepts, I actually have 2 in this case. It crosses in 2 different places. So I have it at x equals -2 and at x equals +2. So you can have more than one x-axis. You could have more than one y-axis. You could have, or I keep saying axis, intercept. It just depends on what your graph shows. So x-intercepts cross the x-axis and are of the form of some number 0. The y-intercepts cross the y-axis and are of the form 0 with a number. And that's it for section 1.1.